All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development 1100 C# programming course, I've been doing a series of kind of introductory videos going through the book and going through some of the things I think are the most important. So I'm in the middle of Chapter 12, and I'm on page 390 here on this product maintenance app. What I had tried to do previously was to take my program that I created kind of as a hybrid between what's in the book and what I wanted to do, and then comment out a ton of stuff and then bring up this product maintenance app. It didn't work very well, so I've actually brought up the one from the book. So what it has in it is it looks like this. Now I don't have these in there, but just to show you how it looks, because I could put those in if I wanted to. So let's just look at the first one here, C# 5950, Murachs C#. So I'll bring up my copy here, which again is the book's copy. So I'll add a product, C#, Murachs, C#. We'll add 8th edition. And 5950. Click Save, and you'll see that now it's been added. In fact, if I remove the other two, it's now the only one that's there. I can't make this really any bigger. I can do that, but that doesn't help a whole heck of a lot. All right, so that's what's in there. And again, I could add the other ones, but I really don't think that matters too much for where we currently are in here. Okay. So I have shown you the product maintenance form, and I've shown you the new product form, and even the confirm delete dialog. All right, so you've seen all that stuff that's in there. So the next figure, as it says, summarizes the products, the methods, and the constructors used in here. Now, in here, we've already worked with this product class. There's nothing new in here. There is a string that represents the product code, a string that represents the product description, and a string, or I'm sorry, and a decimal that represents the product price. Those are the properties. In addition, we have a method called getDisplayText, which takes in some kind of a separator, a string that represents a separator, and allows us to print out all three of the things separated by that separator. Finally, we've got an empty constructor, which, as it says, creates a product object with default values. Now, we're not going to talk about the product DB until later on. And we've got the validator. We went through this line end a while ago, and way back 170 or 160 whatever pages ago, we went over the is present, the is int 32, the is decimal, and the is within range. So we've talked about those already, and I don't think we really have to anymore. So let's take a look at the code. Now we can bring up the code here, or we can bring it up on our screen, on our program itself. It really doesn't matter. So this is for the product FRM product main form. Okay. So in other words, this is the one that comes up when you start running the program. So it says here we've got a list of products, a list of type product that's called product that initially is null. All right. Then in our load event, we call this get products, which is going to go out to our file where we're saving these, and it's going to grab those products, and then it'll call fill product list box. So it'll go through there basically and add them one at a time. All right. There is an add button in there and a delete button and an exit button on there as well. So again, we're talking about what comes up. There's the add, there's the delete, and there's the exit. Okay. So for the add button, notice what we're doing. Just like we learned about in the last chapter, we're creating a brand new form. All right. And then in that new product form, we're calling get new product. And as long as the product isn't null, so in other words, if we left it blank, there's nothing to do. But if we filled in the information. Then we want to add that product to our list of products. And then we want to call save product so that it gets saved back out to the file. And then we want to refill the list box with a new product in there. Delete. We're coming in and we are basically making sure we've selected something where that int I equals lst products dot selected index. If we've selected nothing, the index is -1, so there's nothing to do. But if we've selected a product, so then it won't be -1. All right. Then we are grabbing a new product and we're saying, are you sure you want to delete this product? And it brings up this message box with a confirmed delete. If we press yes, then it removes it. Then it calls save products and it calls fill list box again. And when it does all that stuff, all right, and when it does all that stuff, that product should be removed. All right, finally, you've got a very simple exit routine. Now, what I'm going to do, you don't have to do this, of course, but what I'm going to do is I'm going to go back in here, and in this FRM product main that we've got in here, there it is. In our exit right now, it's just at this dot close. Let's put a little something in there. Let's put in what we basically put in for our exit. So I'm going to come down to here and I'm going to grab this. And we'll see if this works. I immediately want to close this so I don't go changing something in here that I don't want to change. So I'm just going to comment out what they have. And I'm going to put in this. So now when I run it, and I click exit, it says, are you sure you really want to exit the program? If you say no, you stay there. And if you say yes, you exit. I just kind of like doing that instead of just a this dot close. Okay? All right. Now here's the code for the new product form. Okay, so this is where we've clicked the button that says add new product. All right. So we're creating a new product right here of type product, and it's null. All right. Then we've got this get new product, which is going to bring up for us the empty form, this dot show dialog. All right. Then if we click the save button, it'll check and validate the data. What is that doing? That's making sure there is a value. Remember, these are strings for the code and the description, so it's making sure there's something in there. All right, it's making sure that there's something in there. Why? How is it doing that? From the validator class, it's calling the validators is present. Okay, now there's other ways of doing it rather than the way they've done it here, but we're not going to talk about that right now. And you'll notice it's a plus equals. We have no idea the order in which they're going to go through these. All right, they may not fill them up by doing the code first and then the description and the price. They could do it in any order they wanted. All right, then this says if there wasn't any error message, okay. So this, I'm sorry, let me say that again. It's saying if the error message isn't blank, then there was some kind of an error. So we set success equal to false. We just bring up a message box that says entry error. Okay, but either way, we return success. It was set to true at the beginning. So if there weren't any errors, it's still true and will return true. And all the cancel does is it just closes. There we don't want to do what we just did as far as, bringing up the message box, etc. We just want to close. So this was the code for the validator class. We had looked at some of this already. All right, so I'm not going to go over this line end thing, but in here, we've got an is decimal. So we try to do a decimal.parse. Now they're using something here. Can't remember the name of it right now, and I don't know why, but I can't. Let's see if we can find it. showing it to me here, but it's not telling me what the name of it is. It's in our book. All right. And I don't want to go and search. Whoops. I don't want to go and search for it right now. Come on, Jeffrey. Try it again. There we go. But what this is basically saying is if we are able to successfully go ahead and do a decimal triparse on whatever was in there, okay, whatever we chose for the value, it's going to basically put the output in there. And if we can't, it's going to give us a message that says we can't do it. Same kind of thing with an int32. We're just doing an int32.triparse as opposed to a decimal.triparse. And for our within range, this is just a range checker. And it's saying if we put in something less than the minimum we passed in or greater than the maximum we passed in, we won't take it. All right, that's it. And I spent so much time on the last tape going through that I just decided, like I said, it'd be faster to do it this way. All right, it says the topics that follow present some additional skills you should know about. So the first is how to code properties with fields. And they mention that a class can contain two types of fields, instance variables and static variables. Think about this, okay? If I was going to create a whole bunch of person objects, each person object would have their own first name, their own last name, their own height, their own weight, their own gender, etc. Those would be instance variables. All right? On the other hand, if I decided that I wanted to have a counter that was going to show how many person variables I created, I wouldn't want to have one counter with a value of 1 for each person I created. If I create 37 people or persons, I want to have one counter with a value of 37. That's a static variable. Remember, with a static variable, it can be accessed without creating or instantiating the class. All right, but you do have to instantiate it for instance variables. So if we look at some of the examples that are in here, this is a little different from what we did before. All right, so take a look in the middle of the page here. It says a property with a getter that processes the field before returning it. All right, so what they're saying here is if we put nothing in here, it's going to return NA. Otherwise, it's going to return a code for the get. This is setting it. And they're using, as it says, the expression bodied set accessor. All right. You could have just said set and then put an opening curly brace, code equal value, and then a closing curly brace, like this. All right. And they're showing here, as it says, here's a property with a getter that processes the field before returning it. Here's a property with a setter that processes it before returning it. All right. And when we look at the description down below, a variable defined at the class level within a class is called a field. If your property simply sets and returns it, you can use the auto implemented that we've talked about before. But sometimes you've got to make checks on there. So when you need to process a value before you set or return it, you can code the field yourself. And that's what they just showed you. Now, we've talked a little bit about overloading, and when you overload something, and here will be an example. Now, here we've got get display text, and here we've got get display text. But notice the difference between them. In the first case, in the parentheses, we've got a string passed in called sep. In the second example, we've got nothing passed in. Since we've got nothing passed in, we have to let it know when we, that basically it's got to call get display text, but it has to know what to set up as a separator. So look at the difference between them. In the first case, in these two statements they show right here, the separator will be a tab. In the second case, it'll go back and call the default, which will mean that after each field there'll be a comma, a space, and then the next field. You can overload virtually any method you want to or need to overload, including a constructor. We had talked about that earlier, and here is an example. Now, as they mentioned down toward the bottom of the page here, the name of the method combined with its parameters, they form the method's signature. More than one method can have the same name, but each method can have a unique signature. Methods with the same name and a different signature are overloaded. You oftentimes use those. All right. Again, constructors can be overloaded as well. Instead of using overloaded methods, it says to supply default values, you can use optional parameters. We talked about that in an earlier chapter. All right, how to code required properties. Now, this is new. It says C# 11.0 introduced the required keyword that they're going to show you. I've not used this very often. If you put required in there and you don't set it down below to a value, you're going to get an error, as is shown right here. All right, I'm just going to hold off on that one. There's going to be some of this stuff that we will talk about. Property patterns is another one when we're in class. Okay, so as it says here, you can use property patterns to match properties of an object, and then we'll show an example right here. And here's an example of using it within a nested if, and here probably a little easier to read within a switch. All right, and there's even a faster, better, whatever you want to call it, ways of doing it here. All right, so most of this that's in here, I want to hold off on because it's going to make a lot more sense going over this when we're in a classroom environment. All right, the end of the chapter talks about structures, records, and record structs. Now it starts with structures, and as they mentioned there, a structure is similar to a class, but it defines a value type rather than a reference type. So the things in a structure, when you start passing it around and doing work with it, basically they're going to be copies of the data you're working with rather than the address. And as it says, although structures require less memory and instantiate faster, it's considered good programming practice only to use them for when you're working with something with a very small amount of data. So they go back and they redo some of the stuff we looked at earlier. Looks very similar to what we did, except rather than saying public class here, we've now got public struct. All right, and you can make read-only things in here too. So as they mention here, down on the bottom of the page, a structure is similar to a class, but it represents a value type, not a reference type. It can contain the same types of members as a class, i.e. fields, properties, methods, constructors, etc. Prior to C# 10, you couldn't include a parameterless constructor, but now you can. Prior to C# 11, a constructor that accepted parameters had to initialize all those parameters. With C# and later, you don't have to do that. So again, as the language gets more and more mature, whatever you want to call it, things are typically added. And quite often they're added because that's what the people who are using it want to have. So they show next an example of using a structure. And it looks very similar to what we did before. So to create an instance of a constructor and initialize its variables to defaults, you use the default constructor with a new keyword. That should sound familiar. Now, unlike classes, structures can't be inherited. We're going to talk about inheritance a little bit later. All right. Finally, records. Notice a record is much like a structure, but it's a reference type. All right. As they say again, the syntax is similar to creating a class or creating a structure. As of C#10, it says, and later, you can include the class keyword on a record declaration if you want to make it clear that it's a reference type. Now, there's nothing wrong with using structures. There's nothing wrong with using records. Most people will tell you that classes are what they use. It's just much easier to do that. Finally, there's a record struct type. As it says, it also works much like a structure. It defines a value type, but it provides a better equality comparison than a structure. And finally, they show an example of that. You can see record struct. All right. So they update at the end here, they update the product maintenance app to use a record rather than using a class. Nothing wrong with doing this. The code is very similar. All right, but I'm just not going to go over it, not right now. All right, I'm done with this chapter, so what I'd like to do instead is to, in just a minute, jump into the next chapter, Chapter 13, where we will work with indexers, delegates, and operators. All right, and what I'm going to do for chapters probably at least 13, 14, 15, and 16, probably rather than creating my own examples, I'll just bring in the ones from the book. All right, so I'll be back with that shortly.